Hello and welcome to Dramani Online Mathematics. Today we will also be looking at something special under bisection method. And what you are going to look at is how to find the number of iterations. Sometimes the question will ask you to find the number of iterations. How do you do that? Simply, you have to use this formula where the b and the a, as usual, are the intervals. The n here is the number of iteration. That's what you are looking for. Always, this is always less than or equals to the accuracy. The accuracy will be given to you in the question. Okay, so now let's look at this example. Determine the number of iterations necessary to solve with the bisection f of x equals x cubed plus 2x squared minus x plus 10 equals 0. Okay? Oh, it's supposed to be like this. This is equals to that. Alright? With accuracy 10 to the power negative 3. So it means that here we replace it by 10 to the power negative 3. On the interval, so our a, as usual, is what? 1, the b is 2. So that's what we are going to look at it. Alright. So, we know that, okay, solution. Alright, let me use the black marker. So, looking at this, our A will be 1, then our B will be 2. So let's take our formula, which is B minus A over 2 to the power n is less than or equals to the accuracy. The accuracy here is 10 to the power negative 3. So from here, our B is 2, so we have 2 minus 1 over 2 to the power n is less than or equals to 10 to the power negative 3. So this one can be written as 1 over 2 to the power n is less than or equals to 10 to negative 3. Now at this particular point, I can write this one as 2 to the power negative n. From indices, we have done indices. You can check my previous videos, they are there. It's less than or equals to, this is 10 to the power negative 3. Now from exponential equation, we said that if the bases are the same, we create the powers. There's no way that you can make this and that have the same base. And there's no way you can make this and that have the same power. So what do? The only thing you can do is we introduce logarithm, which I will also be looking at it next video. So looking at this one, if I to introduce the logarithm, I will introduce the log on both sides. Okay, so now if I have something like this, remember, because this log that we have here, there's no base here, there's no base, so it tells you that it's base 10. So when you write a log without a base, it's base 10. Now, so it's log 2 to the power negative n base 10. So base 10 is supposed to be here, means that here to base 10 is supposed to be there. Do you understand that? So looking at this, we know that from laws of logarithm, the negative n here can come here. So we have negative n. Is that okay? Negative n log n 2 equals, so this one negative 3 is coming here, so I have negative 3 over, sorry, not over, let me do this. So that will give us negative 3 log 10. Good. So since we have this, what do we do next? It's very simple. This is here, that is here. We are interested in the n. Is that okay? Please, this side is less than or equals to that. So I have to divide both sides of the equation by log. So let me make it negative log what? 2. So here will be negative n log 2 over negative log 2 equals negative 3 log 10 over negative log 2. Alright, so this will go with that. So I have my n. Oh, sorry, why am I bringing equal sign? So this will be less than or equals to. Now, this negative will go with this. We have 3 log 10 over log 2. In fact, log 10 base 10 should give you 1. But you can also decide to maintain it. Is that okay? Yes, you can decide to maintain it. So if you do that, we have 9 points. So our n is less than or equals to 9 points. 96578. So n is less than or equals to 1 decimal place. You have 10. Wonderful. Look at this. This tells you that you have to conduct 10 iterations before the thing will converge. 10 iterations. So this is how we find the number of what? Iterations. Now you can also look at another example. So let me clean this slide. Let me maintain my formula so that you can still copy from there. Yeah. All right. So let's look at another example. So example number 2. Determine the number of iteration. So iterations necessary to solve x minus 2 to the power negative x equals 10. So it's supposed to be right. X minus 2 to the power negative x equals 10. And we are saying that x is between 0 and what? 1. Alright. Then with, let me give you the accuracy. With accuracy of 10 to the power negative 5. So this is the question. I have my solution lying down there. So you should determine the number of iterations necessary to solve x minus 2 to the power negative x equals 10. Then we are saying x is between these intervals, okay? So our a, you can guess, which is 0. Our b is 1. So with this, the accuracy has been given as 10 to the power negative 5. So the formula now becomes b minus a over 2 to the power n is less than or equals to 10 to the power negative 5. So from here, our b is 1, so I have 1 minus 0 over 2 to the power n is less than or equals to 10 to the power negative 5. So I have 1 over 2 to the power n less than or equals to 10 to the power negative 5. So 2 exponent negative n again from indices 10 to the power negative 5. So I take my log on both sides. So log 10 to the power negative 5. So on both sides, it tells you that the log applies. So I have my negative n here, log 2. The other side will be less than or equals to my negative 5 here, log 10. In fact, this one is 1. Log 10 base 10 is 1. So you can also convert it. Now, I still have to divide. I want to make n the subject. So I have to divide both sides by negative log. So I have my n equals, I'm bringing the equal sign again, negative 5 log 10 over negative log 2. This and that are the same, so they will go. So my n will be less than or equals to 5 log 10 over log what? 2. So if you do this carefully, you are going to have 16.609 16.609495. So let's leave it in one decimal place. That gives us 17. So this tells you that the number of iterations you need to do to solve this question is 17 iterations. Thank you very much for watching. Please try to share, subscribe to your friends to also benefit from this. Thank you.